Welcome, everyone, and thank you for joining us. My name is Juliet, and I'll be the moderator for today's webinar. Before I pass it over to our speakers, let me cover a few housekeeping items. At the bottom of your screen are multiple engagement tools you can use. All tools are resizable and movable, so feel free to move them around to get the most out of your desktop space. You can expand your presentation area or maximize it to full screen by clicking on the arrows in the top right corner. If you have any audio or video issues, you can find some answers to some common technical issues located in the Help widget at the bottom of your screen. Please note that a copy of today's slide deck and additional resources are available in the resource list. Please have a look and download everything that you may find useful. Also, the webinar will be recorded and sent via the email you register with. Lastly, if you have any questions during the presentation, you can submit them through the Q&A widget. We're here to answer you live via the chat, so don't hesitate to reach out throughout the presentation. Now, I'd like to briefly introduce our speakers. Today, we're joined by Mike Johnson. He is a co-founder and trainer at SE Training. Mike has worked leading challenging product development roles in the space, defense, and medical sectors. He has worked predominantly in the roles of systems engineer, leading technical developments involving interdisciplinary teams, often consisting of mechanical, electrical, technology, software, and optical engineers. He is now passionately applying his experience and knowledge of systems engineering to the healthcare industry. He is passionate about product development and especially the application of systems engineering. We are also joined by Vincent Balgos. He is the Director of Solutions and Consulting here at Jama Software, where he currently leads the medical device and life sciences solutions team. Prior to joining Jama, he worked in the medical device/IVD industry for over 17 years with roles in systems engineering, product development, and project management. Vincent has a successful history in launching new products to the global regulated market and his experience in product development, risk management, quality systems, and medical device regulations. And with that, I'll pass it over to you, Mike.
Thank you very much, Juliet, and thank you very much to all the people of Jama Software for supporting this webinar this evening. The topic is Systems Engineering MedTech Challenges. I'm Mike Johnson, and I'm working for a company called SE Training GmbH. Give you a little introduction on tonight's topics. So firstly, I have a short introduction about SE Training, the company I co-founded. Then I want to dive into practical perspectives, aligning systems engineering, challenges, systems engineering opportunities, tips and tricks overcoming common obstacles, and we have some time then at the end for a wrap-up, summary, and questions. A short introduction about the company SE Training. We are a group of systems engineering experts working on the development and support of technically complex systems. So very much the technical complexity is the thing that unites us all, and is very much what unites the systems engineering approach. The problems caused by complexity are often very multifaceted, often have a lot of non-linearities, many dependencies, etc., and it's not easy to overcome them. We are an endorsed training provider by the INCOSE UK group. So INCOSE stands for the International Council on Systems Engineering. We are accredited here in Switzerland by the EDQA training accreditation. And many people come to us because they would like to achieve one of the accreditations in INCOSE. That's the ACEP, the CSEP, or the ECEP. And ACEP is the Associated Systems Engineering Professional. CSEP is the Chartered Systems Engineering Professional. ECEP is a very experienced. And of course, with both the ACEP and the CSEP, you need to take an exam. And it's not an easy exam. You have to revise quite a lot for it. And so we have a dedicated training course to prepare you for it. Also, for anyone in Switzerland, which may be quite a few people in this webinar, anyone working in Switzerland, if you're working as a temporary worker, then you can find us on the tempservice.ch. So the challenges for this webinar that we're trying to overcome. Firstly, I want to talk about the practical perspectives on the context and constraints. I want to talk about aligning systems engineering implementation initiatives with the applicable standards. ongoing challenges in the medtech industry, opportunities and tips and tricks for overcoming the common obstacles in highly regulated industries. Right. Short introduction about myself. I'm British, which means sometimes I make silly jokes. That is, of course, what the British do, right? And in growing up, I attended the University of Exeter firstly to study physics. Following my undergraduate in physics, I went to the University of St Andrews to gain my master's in optics and optoelectronics. There, my first job was at Thales Optronics in the UK, and already from a young age, I was a systems engineer. I was always a systems engineer in my early career. Firstly, working as an optical systems engineer, especially working with the military. And many of you may know the company Thales. Thales are very big on systems engineering. It's definitely a core competence there. And there I was able to, already at a young age, deliver a very big Category A project for the infantry on some very complex systems. I then moved to Switzerland, and in Switzerland I moved to a space company called Ruag Space, which is now called Thales Alenia Space Switzerland. And there, as well as leading the systems engineering group, in addition, I was also a systems engineer, and probably my best application of systems engineering in that time was on the very, very quick development of a space telescope called CASSIS. The CASSIS is on the ExoMars Trace Gas Orbiter. It's been in orbit since 2017. And we had to do end-to-end development and verification activities, etc., deliver in under 2 years, which really, really was challenging. I must say, though, really also a very good application of systems engineering, especially from a value-oriented perspective. There, after 5 years at Ruag Space, I moved to Roche Diagnostics. I moved to the MedTech industry. There, I was head of systems engineering in the molecular division, so especially all the systems there using PCR, or the polymerase chain reaction. I was there for 7 years with a group of about 30 people, business analysts, systems engineers, requirements engineers, etc., really specializing on a lot of the upfront product definition activities on these, again, very complex systems, whether they're pre-analytics or analytics systems, both equally very, very complex. Many aspects that you need to consider. You can't just go in and start writing software or start cutting metal as such. Also introduced many organizational initiatives across the whole of Roche Diagnostics, not just in our site in Switzerland. And then since the last 2 years, I've been full-time with my company SE Training as a consultant and trainer. So for this webinar, firstly, the first topic I want to talk about is practical perspectives. The importance here of considering, firstly, many aspects of medtech context and constraints. And I say this, of course, based a lot on my history. And my history is that I've come from the strong systems engineering background in aerospace, defense, and then come into medtech. So of course, my views and my reflections are based very much on my experience here. May not be the same for everybody. How do I see things? Well, number one, it's a very high compliance driven development process, right? So it's very important in medtech that you show evidence for what you've done, right? Or what you said you were going to do. That's really important in the development processes. Now, of course, if I'm just making a very simple product, just a few requirements, a few verification activities, well, that's not so difficult, is it? But of course, if I'm making very complex systems, I have many different subcontractors supporting them as well, many aspects possibly changing, then actually having that evidence to show compliance is really important, especially that I've got a high level of confidence that everything is available and is consistent. Otherwise, I'm open very much for a lot of liability, right? So you're going to expect that in this industry. In particular, in medtech, the development process is very centered around usability and safety. Now, of course, safety is called product risk, but it's a term that I must say I'm not a particular fan of. I'd rather we call things safety. But these are core to the development processes, right? So right from the beginning of the development, that you circle around usability and safety is absolutely critical. And of course, we know why, or any of us working in the medtech industry know why, because we've seen how both usability and safety can lead to, of course, in many cases, deaths, unfortunately, from the misuse of medical devices or from reliability issues, etc. I mean, as medical devices you could be connected to, which if they failed, you could be dead within a 2 or 3 minutes, or seriously injured within 2 or 3 minutes. So of course, these two quality attributes or ilities or emerging or engineering specialities or emergent properties, whatever you want to call them, these two in particular are very, very critical. And of course, we know that as we go through the development processes, we need to circle around them. In both these cases, we should already be thinking we want to be supported in implementing and executing these processes. Just so that I absolutely say something that's obvious, there's high pressure on time to market, right? No one's in denial about that. That's probably one of the critical constraints on any project you work on in medtech is the pressure to get to market first is absolutely as high as you can imagine from any other industry. Often, of course, projects are dropped purely because they're not achieving their timelines, or simply a competitor has moved in, an unexpected competitor has got their product to market before you. Really, really critical time to market. And that's where actually from my time in the space industry, I can relate to that as well, with our developing telescopes. I mean, if we were late, we simply wouldn't get onto the rocket, right? We simply wouldn't have gone to Mars. So actually that's quite similar. I used to say to people actually in the medtech industry, I used to say to my colleagues often, imagine it's a space rocket that you're trying to get your product onto, because the product, the space rocket doesn't wait for you. I say this as well after working across all three industries. What I saw in medtech, often technically the most complex systems, especially when you start analyzing the complexity of the system of systems that they're operating within. And interestingly here, it's not just that it's a very high level of complexity, but also what I often saw in medtech was that the complexity was underestimated. Or people weren't realizing just how complex these systems were, whether they were taking over jobs that people could do, so automating activities or doing, some very high level chemistry for the samples. But whatever they were doing, it's often the people themselves didn't realize just how technically complex these things were, which I would say is actually quite different to the aerospace and defense industry. Often there, actually, I found that you didn't so much underestimate the complexity. You were more aware of the complexity. Often, actually, I think you could do overkill. You could do too much to try and navigate your way around the complexity. Whereas in medtech, I often found it was quite underestimated, and yet these were really, really complex systems. So after the contextualization of constraints, look at the aligning with standards. Now, of course, the one big standard we should all know is the ISO 13485. Very interesting if you do a control F. So you look what's in the ISO 13485 standard. Of course, you won't find the word systems engineering. So having failed on your first control F, you start to look for other words, don't you, right? You say, well, what is there that is systems engineering? What do we find in there? It's clear they want to see a high level of traceability throughout the design and development process. Now, you think typically that products can be developed, like mid-complex products maybe developed 3 to 5 years, kind of scales, things like this, 3 to 5 years. Um, and well, in that 3 to 5 years, what can happen? A whole load of things can change. Your scope can change, your design can change, your verification can change, right? A whole load of things can change. Project team members can change, subcontractors, suppliers can change. All these things, of course, can change, right? And and if at the end of it you say, well, the regulator comes to you and says, well, where's the evidence that you did what you said you were going to do 5 years ago? And you look back at them with a bit of surprise, and you've got no way of showing that evidence through the traceability of the process, and of course you're in trouble. Which again is often why we will have infrastructure supporting us through that process.